Hello, and thank you for joining us for today's webinar, Teaching Linear Regression Using Rguroo. My name is Alex Wunderlich, and I'm an educational courseware specialist here at Hawks Learning. Our speaker today is Dr. Mori Jamshidian of California State University, Fullerton. Dr. Jamshidian is a CNSM Distinguished Professor in the Mathematics Department, where he serves as the Graduate Advisor for the Master of Science in Statistics, and his past positions include Associate Professor of Statistics at the University of Central Florida and Senior Statistician at the BMDP Statistical Software. His area of research is broadly in computational statistics, with publications in major theoretical and applied journals, such as the Journal of the American Statistical Association, Journal of the Royal Statistical Society, and Psychometrica. He's currently an associate editor for the Journal of Computational and Graphical Statistics, and in the past has served as associate editor for the American Statistician, Journal of the Statistical Software, and Journal of Statistical Computation and Simulation. His current activities include research in statistics education and development of statistical software for teaching statistics. We are excited that Dr. Jamshidian is here with us to share his expertise. And we ask if you do have any questions during the webinar, please enter those into the Q&A box located on the panel at the top or bottom of your screen, and we'll then address them at the end of the talk. And on that note, I'll hand it over to our presenter, Dr. Jamshidian.
Hello, everybody. Thank you for joining us in this webinar, and thank you, Alex. So let me begin. We are going to be, as Alex mentioned, we are going to talk about using Rguroo to teach linear regression. And so the way this webinar is going to go is I will start with giving a very quick overview of Rguroo for those of you who are not familiar with Rguroo. And then I will go essentially through a linear regression exercise, mainly to show the tools that you would need in order to teach Rguroo and demonstrate the tools that are available in Rguroo. So without further ado, let me just begin with the introduction of Rguroo. So generally, this is our webpage, rguroo.com. Generally, students would log in into our website, into the Rguroo application. There is no download required. It is just a web application. You would just get an account and you would log into your account. For this webinar, I'm going to use our development site, which has the latest and the greatest stuff. I should mention that everything that I use in this webinar is also available in the site or in the version that is available to the public. So let me just go ahead and log into my account. So the Rguroo application consists of 4 main sections: data, plots, analytics, and probability and simulation. And so in the data section, you have the main usual thing where you can import data. In fact, you can import data in various formats like CSV, Excel, SAS, SPSS, etc. And once you upload the data is stored in the cloud, and it will be available through the applications, every application within Rguroo. Then you have a data repository, which I will talk about, and also we have RGR files, which are for sharing projects between Rguroo users. I will talk about that as well. In terms of data functions, we have summary statistics, sort, subset, transform, merge, and append. I will use in this talk the transform and the merge function later on, so you'll see how those functions are used. The next thing is plots. We have various plots: bar plots, box plots, dot plot, histogram, pie charts, scatter plots, and stem and leaf. In particular, dot plot is a new program that doesn't exist in the production that you are in the version that's out there, but in the version that we are going to be releasing soon, you are going to have dot plot also added to the graphs. In the analytics section, we have one population and two population proportion, mean inference, one population, and one and two population. Mean inference, linear regression, tabulation, goodness of fit, and also contingency tables. I will talk about linear regression today in details. Finally, in the probability and simulation section, we have probability calculators, continuous and discrete. And so essentially all the distributions that are available in R are available within our continuous and discrete calculators. So again, I probably should mention the name Rguroo comes because our computing engine really is the R computer language. In the random generation, you can generate random values from many different distributions. For example, if you want to demonstrate the central limit theorem or other statistical concepts, random selection is quite useful for doing bootstrap, sampling distribution, and so on. If you go to the top right here, you see a video icon. And this video icon, if you just click on it, you see the collection of the videos that we have. And you can search the videos by keyword. For example, if I just type in confidence interval here, you'll see all the videos that are available for confidence interval. Finally, this will take you to our user's guide, which contains plenty of examples as well as technical documentation in terms of how all the components are computed within Rguroo. So with that, let me start with the main topic, which is regression analysis. So let me open up the linear regression. So within analytics pane, there is this linear regression. You just click on it and you get the dialog box for the linear regression. I would like to review what we are seeing here. So notice that there's a basics, details, and level editor buttons here. Essentially, all of our analyses have these three buttons. The basics button essentially leads to a dialog box that has the basics of every analysis, so it's not complicated. On the other hand, the details section, and I will use it today a little bit later, in every analysis would contain details, advanced method, advanced techniques that you might need to use, or some sort of additional work that you need to do. You'll just use details for it. And then there's a level editor, and the level editor mainly is to manipulate levels of a categorical or a factor variable. You can also see, I will use the level editor also today in my talk when I introduce multiple regression. Then you see the word icon, and this word icon is for exporting whatever report you have to Word. I will do that as well. And here you can see also that within this application, there is a video icon. So within every one of our applications, there is a video icon that goes with that particular application. And you can see that, a video shows up right there, and students can watch the video and see how to use that particular application. You can see, for example, here that we have closed caption, and that's mainly because we are always committed to accessibility, and so if you don't want the closed captions, you would be closing those. So that takes care of that. So let me, with that, let me begin our data analysis. So I thought that for our data analysis, I would start with the classical or the historic Galton data that was collected in the 19th century by Sir Francis Galton. And in fact, I believe that was the first time that the word regression was introduced because of this data set. So many of you guys may know that that data set is about relating parents' height to their children's height. So this data set is available in our repository. So let me just go ahead and open our repository. So I go here to data import and I open our repository. So within our repository, there are over 2,000 data sets that you can use. In particular, there are R and R packages data sets that you can use. All of the R packages data sets are here. And in particular, if I just put hist here, so let me, yes. So hist data is an R package that has many historic data in it. And in particular, it has the Galton data. So let me just go ahead and type in Galton here. So you see that there is the Galton family. And if you noticed earlier also, there are these information, you get how many rows are in each data set and how many columns. And in particular, there's an information icon here that I just click, and then I get information about, about the variables in the data set, etc. And for example, it would be nice if you're teaching regression to show students. Let me just open this here. It shows, for example, how people gather data. This is actually Galton's notes that we see right here. So a bit of historic stuff would be interesting for the students. So in order to import the data, I'm going to actually, this first one is the actual data that Galton used. I'm going to import this, and you'll see that the data that are available in the data repository are pretty easy to import. All you do is you just double click on it, select it and click import. And notice that this Galton data opened here. And I have actually have a folder here that I have prepared, that I have constructed before. I'm going to just go ahead and put this Galton data in here. So we are going to put all of the data sets for today in this folder here. All right. So with that, now let me go ahead and show you what the goal is here. So, sorry, let me just go ahead and open my PowerPoint here. So I want to start with a simple regression model. And essentially, in the simple regression model, I'm going to look at the relationship between children's height and mid-parent. Mid-parent was the terminology that Galton used. Essentially, that means the average height of mothers and fathers. So let me just go back to our guru here. And maybe we should take a look at the data. So this is the data set that I imported. X here is just the case number. This case number was added by our guru. This is the family number, like family 1 had 4 children. So this is the family ID. This is father's height for this family, mother's height, and then the sex of the children. And the height here represents the height of their children. And in this case, there were 4 kids. So if you look at the first 4 cases, there are just family 1, and then there's family 2. Down here, you see that there are 898 cases that we have imported. Okay, so I need to go and do my analysis. I'm going to now go ahead and open the regression dialog box. And you'll see that all the data sets are available here. And I'm going to just choose Galton here. And so my response variable here is height, which is children's height. But now I need the average of father and mother's height. One way to do this is if you know R, and for more advanced students, I can just actually go ahead and write, just double click here, father plus, I'm going to have mother. And then I'm going to just find the average divided by 2. And then, in R, for this expression to be calculated all together, then you would have to just put an I parentheses, close parentheses. And, if you just go ahead and do this, you're going to get, your regression. But I think for introductory students, this is not really a good way to go. You might not want to introduce all of this, and you might want to actually create this data, which is the average of father's and mother's height, and then either give it to them or teach them how to use the transform function to come up with it. So what I'm going to do is I'm going to be saving everything. So let me just go ahead and add a folder here, call it Hawks Learning, or let's call it Hawks Webinar. Okay, I'm going to save this. I will be sharing all of these at the end with you. This is, let's just call this model 1, report 1. Okay, so now, this model 1 with report 1 got generated. I'm just going to put it in the Hawks webinar folder. All right, so what I want to do is I want to avoid this complication here. So I will go ahead and let me just close this. I will go ahead to the data transform here. So this also gives the opportunity for me to show you different functions that are available in Rguroo. So I'm going to go ahead and select our data Galton. Okay. And then I'm going to add a new variable. So what you can do in data transform is you can add new variables that are transformations of the existing variables, or you could use any R function to actually create variables here. So let's call this mid-parent, as was called by Galton. And I'm going to notice that as soon as I click here, the mid-parent shows up here. I have to define it now. So it's going to be, and instead of typing, it's best to double click here so you don't misspell the name of the variables. So that's what I'm doing. So it's, oops, sorry, not family. I need father plus mother. Okay. Divided by 2. All right, so that will create a variable for me, which is the average of the father's and mother's height. And then what I like also to do here is, you see that the height was the height of children. Just to make sure that we understand that this is height of the children, I'm going to just add this and say, call it child height. And so I will add, sorry, let me just put the height here. Okay, so if I just run this, I do get my 2 variables that I generated. This is child height, this is mid-parent. Let me clean up this data set a little bit here. What I want is, let's just put the case numbers at the very beginning here. Okay, and let's see, did I do it? I guess I didn't. Okay. And, I already created child height, so I can just exclude this variable, and I don't need number of kids for my analysis. So this is just a little bit cleaned up version of our data set. So in fact, let me just put sex a little bit on higher other also, because those are the variables that I need most. All right, so now I have this data set. So you could either teach the students to do this on their own, or you could simply do it on your own, and if you just, click on this, you can just download it and share it with them as a CSV format. But what I'm going to do is I'm going to save it here right now. I'm going to save this as Galton 1. Okay. And so notice that there are 2 things here. It says save as, and it says save parameters. So if I uncheck this, I just save this as a standalone data set. But if the save parameter is on, then I can always come back and see how I created this data set and even continue working with it. So let me just keep it like that. So it says Galton 1 saved successfully, and notice that there's Galton 1, and you see the transformation icon in here. And I'm going to just go ahead and put that also in the Hawks Learning webinar folder. In fact, just so that we don't see these variables anymore, I can go ahead and filter things out and just have Galton here so that we just see Galton data sets that we have generated from this point on. All right. So we have now saved our data. So let's go back to the regression and open our regression analysis. And so notice, by the way, that only the data sets that I have filtered show up, and we're going to start working with Galton 1. And now I have the child height as a function of mid-parent. That would be my simple linear regression that I have. All right, so let's just go ahead and run this. By the way, the I is for preview and running the what we have in the dialog box. So let's go over the output. For one thing, I should say that all of our outputs are really eye-pleasing. If you compare to other software, you'll see that these are much cleaner and much nicer output that you get. So we begin with the cases that are used within the analysis. There are 898 cases with no missing. You get the usual regression coefficient estimates, the intercept, and the slope here, and of course the usual p-value and t-value. You get your r-squared value, which in this case is relatively low, 0.1, and you get the correlation, you get the ANOVA table, you get the residual versus fit, and you get the normal probability plot. Okay, so this is the default output that you get for a regression analysis. Now, if you just go to details, here in the very first tab, it says model estimates and diagnostics graph. You see that you can actually have plenty of graphs and tables that you can add to your output. And in fact, you can just play around with the output here. For example, if I want to have my residual plot at the very beginning, I can just do that. And you'll see just that the residual plot, for example, shows at the very beginning, right? So with that, let's just, for example, do something. For example, let's do the X versus Y plot, which is response versus predictor. And let's just, let me just remove this, and let's just keep it basic. Let's say, let's not have ANOVA table and adjusted r-squared. I just want to show you something. So for example, if I put this here, now I have a very simple output where there's a table at the beginning and there is a graph and then there's a table at the end. So I can now export this to Word. And by the way, let me just save this as model, let's call it model 2, report 1, because I want to have everything saved here. Okay. All right. So let's just export this to Word. So in order to export to Word, all you do is you just click this Word icon, and then it will prompt you to where you want to actually put the report. So this also depends on your pop-up blocker should be off, and also depending on your browser setting, it might automatically go to your download folder. In my setting, it asks me where to put it. I'm going to put it on the desktop. Let's just say I call it Galton zip. So what you're getting is really a zip file, which I want to show you what it contains. So it did generate the Galton zip for me. And if I just now come here, you see that it is a zip file sitting here on my desktop. If I double click on it, I will just extract the zip file, and it says it has 3 items in it, right? So there is the report, the Word, the HTML, and there's a graph. So the HTML is a standalone HTML that you can have as a separate file. We also, every graph that is in your report also, there will be a standalone PNG file for it so that you can import it into whatever application you want. And then you can also open the Word document, which has the report in it, right? So one thing that you see now here is that within this Word document, the graph is not showing. If you have an older version of Word, this is going to really just show up without any problems. But if you have a newer version, in the newer version, these graphs are links, and for security purposes, they just want, you can just go ahead and grant permission essentially for this graph to show up in the document. So what you do is you go to edit, you say links, and you select the graphs, and it says save pictures in document. You just select that and you say okay, and you have to select that here, and you have to grant access. And once you do that, my graph showed up. The graph is going to be big. As I said, we generate our graphs larger just because so that there's more flexibility for users to use them in other applications if they want larger graphs. But you can simply, now you're in a Word file and you can do whatever you need to do in a Word file. So this is a very useful feature, especially for students that need to just export something from R and and do some, write explanations, etc. All right. So with that, let's go ahead and do more detailed analyses here. So what I'd like to do is I'd like to go to the diagnostic indices and tables. You can see that we have a whole bunch of diagnostics, standardized residuals, DF betas, covariance ratios, etc. And what I'd like to do is just take a look at, the residual versus fit you saw here, but suppose that you want to do further things with residuals and other diagnostic indices, you can actually save them and export them. And let me just go ahead for this particular talk. I'm going to just take the residuals and also the predicted values. Okay. And I am going to say include diagnostics. When I do that, then what I'm going to get is actually all the residuals and predicted values here. Then I'm going to go ahead and save this data as a table. So let's call it residuals, or Galton residuals, let's call it. Okay, so we do that. All right. So first of all, note that I save this data and this now becomes part of my data sets here, right? So let's just go to, so let me also save this as, let's say model 2, report, let's call it report 3. Okay. All right. So let's go and do a little bit of plotting here, and I'm going to go to our scatter plot. Okay. And what I want to do is I want to actually do a scatter plot of X versus Y here, first of all. And so let's just go ahead and bring in our Galton 1 data. Okay. And I'm going to go ahead and do my X is going to be the mid-parent height, and my Y is going to be my child height. And if I just draw it, this is the graph that we saw actually in the output, all right, of the X versus Y plot, right? You can also get the least squares line here. And if I do that, I'll get a least squares line. And in fact, to show the regression in to the mean, the idea that Galton had, you can superimpose this by the line y equal to x. So here you would be able to superimpose text, line, and curves, but it's easier for me to just do this as a curve. So I'm going to just do the line y equals to x. And just so that it is more clear, let me just make that maybe dot it and make it a little bit thicker here. This you can just do use different colors, etc. So let me just do that. So now you can see that. I guess I didn't choose a very good color here. Let me just try to do a better job here. So let me go with solid, and maybe a red color is going to show up better. Okay. So here, essentially, the idea of regression to the mean, which means that, you know, taller parents have shorter children. On average, taller parents have shorter children, and on average, shorter parents have taller children, actually can be explained in this graph. And notice that, by the way, you have also the equation of the line here. Now, what is more interesting here is that if you just go ahead and do this by factor here, you would be able to get the least squares lines by factor. So let's LS line by factor. And now you can show students that something is going on. Essentially, boys are taller and girls are shorter, and you can see that the least squares line for the girls is different than for the boys here. So you can see there's females are the blue ones and males are the green ones. You get all the information here. So this suggests that you probably need to have you know, another covariate sex to this. But I also did something. So let me just also save this scatter plot as let's call it plot 1. Okay, and I'm gonna just put it in Hawk's webinar. Okay, so I have this now. You wonder what happened to those regression residuals that I had. So you know, in multiple regression, if you have multiple regression, you don't have the X versus Y plot. You want to show residuals. So the residuals that I actually have, I just generated this data, which was residual versus predicted, but I want to plot them versus sex. So, but sex is not here. So I can use the merge function in Rguroo, and I will just use my Galton 1 data set and my Galton residuals, and I'm going to merge them according to the cases. So if you recall, X was the case number for Galton 1 data, and the observation number is for the Galton residual. And now I have actually generated a data set that has the residuals here. So let's call it Galton with res. All right, and for example, just to do something quick in to show you how we can essentially work with these residuals in more detailed ways, I'm going to just do a scatter plot here, and I will just choose the Galton with resid. Notice that also the merge sign is here. It means that's the merge data that you have. So again, the X is going to be the predicted values in this case, and the Y is going to be the residuals. Okay, and if I plot it here, then I get this. Let me just put the line, the horizontal line at 0. So if I say 0 times X, it puts the horizontal line. Oh, sorry, I have to add a function here. 0 times X. And let me just make it a little bit bigger, and let's make it red. Okay, so you have that. And now if I just go ahead and plot it by sex, for example, then you can see that, you know, again, in the residuals, it's showing up that there is an effect of male and female. By the way, here you can also identify outliers if you wish. So if I just go to basics here and say outliers, then I can just go ahead and identify outliers by, for example, family number. So it seems like there are 2 outliers here with family numbers. Maybe you want outliers that are in the Y direction. You could just go again to the details here. And in the outlier, I know that I'm going too fast, but I'm trying to show you different capabilities. Hopefully by reviewing this video, you will be able to see what I'm doing. So if you go to identify outliers here, and you can just say identify outliers that are in the Y direction. And so you see this is family 155, 35, 72. Of course, if you needed to identify more outliers, you can do that as well. All right. So now with that, let me also save this plot as, let's call it plot 2. Okay. All right, now let me just put it there. Okay, let me close this. All right, so now let's go and do a more general model. So we know that sex has makes a difference if you add it. So let's just go ahead and do a more general model. So the model that I want to do next is this model, where I'm going to be looking at children's height as a function of the factor variable gender and father's height and mother's height. So let's go ahead and see how we can do that in Rguroo. So again, I'm going to go to Analytics, Open Regression. I'm going to use my Galton 1 data. And here, again, my response is the children's height. And now I want sex plus mother's height plus father's height. So plus father's height. Again, you can type here. You can write any kind of function that you like here. You can even do transformations here. For example, if you wanted to do log of the response, you would just put log of, you simply type log of, whatever you need here. It's you can just type in any R code within these boxes here. So let's go with this model. Oops. Oh, that's because I messed up with my variable here. A child log is not there, it says, which is correct. Sorry, child height it is. Okay, so there we go. All right, so now here we got the multiple regression model. And now you can see, for example, that we got our coefficient estimate. Notice that the reference level, it says, is sex female. And sex male is here, mother, father. We got quite an improved R-squared value. We got our analysis variance table. You see the residual versus fit plot. Again, you could export the residuals and see that these are the residuals for the boys and girls. And the normal probability plot looks pretty well, pretty nicely. So things are looking good. One thing that you might wonder is, well, is this always, maybe I don't want the reference variable to be female. So this is what the level editor is for. So if you go here and you click on the factor sex, in general, in the level editor, you'll see all the factors showing up here and all the levels, and then you can play around with them. So first of all, let me just actually relabel this as, I'm going to just do it parentheses female, so it looks better in the output, and parentheses male. And if in R, the very first level essentially is the reference level. So if I want male to be the reference level, I just push it up to the first level, and I just say go. And now you can see that the reference is just male, right? Again, if you wanted to do, for example, not have a reference level and not have an intercept, then you would just do the -1, and then in this case the intercept is gone, and you wouldn't have an intercept. So let me just go back to the model with the intercept here. Okay. All right. So I want to show you some other stuff that are available in the for the multiple regression that are more relevant to the multiple regression. Again, you've got a whole bunch of stuff. Since we have already seen all of this, let me just remove these and just bring something new here for you. So for example, the data correlation matrix is available. You have for example, there is a plot of the, let me see, I have, let me go to plots. Yeah, response versus predicted for factor levels, for example, is available. scatter plot matrix is available, or added variable plot, which is something more advanced, is available. So if I just go and show that, then you can see that. So it depends on the level of your course. Of course, the correlation matrix is given here, and you see the correlation between all the numerical variables. This is the box plot for each of the levels of male and female versus your response variable here. And then you get this scatter plot matrix, which shows the relationship between all the variables pairwise. For example, if you just look at this row, it shows the relationship between child height and mother, father, and sex, and so on. And finally, the added variable plot, which is a little bit more advanced, where, for example, in this plot, you're looking at the variable child height, where all the other, the effect of other covariates besides mother is taken off, and the effect of all the other covariates besides mother is taken off, and the plot is shown. So, for example, let me also save this. So let me call this model 3. I guess I could call it whatever I need. By the way, as long as you do not change the model, you can keep adding the report. So that's why there are reports here. So you can see here, for example, I have 2 reports under the same model here. Okay, so with that, let's see, let me just go ahead and show you how we can do prediction. So let me bring up my PowerPoint. So what I want to do here is, now I want to show you how to do prediction. Well, I have put, my height is 67 inches and my wife's height is 64 inches. And I could, for example, predict the height of our children if they are male. And also I have an example where we could predict the height of our children if they are female, so 67, 64 female. And then a friend's height is 70 and his wife is 67 inches. And we are going to predict the height of the girls for that friend. Okay, so with that, let's see how we can do prediction. So to save time, let me just make this. Okay, there we go. So to save time, I have actually prepared a data set here. So essentially what you have to do is add to your data, the data, so the family, it's Mori's boys and Mori's girls and my friend, right? These are the mother's height, my wife's height, 64, 64, and my friend's wife, 67, and father's height, 67, 67, 70. What is important here is that for the response variable, you don't care about anything else, but here for the response variable, you need to have it missing. As soon as you do that, then it will consider these cases as external data and it will do prediction. Okay, so I'm going to just go ahead and use this to do my prediction. Let me just go to analytics here. Again, just go to my linear regression, and I'm going to go ahead and use now the prediction data. And I'm going to go ahead and use child height, and let's use the same model as before, which was mother plus father plus sex here. And now what I'm going to do is I'm going to go to details here, and you see here it says there are fitted values and predictions. And so let me just go ahead and remove these here. There are standard error prediction. Let's just go with predicted value and prediction interval here. Okay, and these are external data. That means they won't be used in your analysis. And so I could identify them by family, for example, and I could say go. And now down here, you see this. Let's just get rid of the extra stuff that we don't need because let me just go here and we don't need to see any of these here. Let me just remove these from the output so we can see this better. Yeah, so here we go. So here it says case-wise external data prediction. Mori's boys, it predicts 68.347 inches, and it gives you a confidence interval of between 64 to 72. I have 3 boys, and they're all within this range. I don't have any girls, but if I did, this model predicts that they are between 59 to 67 inches, and my friends' girls are going to be between 61 to 69 inches. I'm going to also save this one for you. Let's call it model 4, report 1. Okay. All right. So with that, I guess I have given you the basics of what is in regression. And so what I want to show you now is the feature of RGR. I'm going to put all of these files into Hawk's learning. Let's see. Let's just put it in this folder. So this is what I would do when I'm finished with my lecture. You know, I have all of these things. For example, all the plots, all the you know, whatever I have done with the data, etc. You know, in a folder, right? And let me just close these here. Yeah, I can put all of these in the same folder. Okay. And you know, you can export these as RGR files. So let me just do this just for Hawk's webinar, for example. If I just go ahead and right-click here and say export as RGR, then I'm going to get a file called Hawk's webinar RGR, right? And I'm going to, let's say, save it on the desktop here. So I get a file that is, you know, Hawk's webinar RGR. So you can log out and you can share this file with anybody that you like. And what they can do is they can import this file and they get everything that you have. For example, right here, let me just go ahead and import this file. So if I go to data import and say RGR, okay, and I just say choose file, and I'm going to go to my desktop, and it's sitting right here. I'm going to open it and I'm going to upload it. Okay. Yeah. So notice that it says archive file imported successfully. And, you know, there's a date here, 10/18/19, which is today. The time here is GMT. So, so that because we have people all over the world, we can just use the GMT time here. The data sets that I have used are all now here in this imported thing. And if I just go to analytics here, you see that this imported file, let me just move it a little bit down here so you can see it better. Yeah, so you can see that all of the structure, the data structure that you have is here. All of your data are here. For example, if I click on this, you'll see that the very first report that I had, which was, you know, or this one is actually model 4 that I did, not model 1. If I just, for example, click on model 1 here, right, which was the first report, you can see that you're here. You know, remember this was the one that was more complicated when I wrote it, right? And you can actually continue working. Students can continue working from where you have left off. One thing also is that you can, of course, move this around. You don't have to keep it in this folder. Since I have a Hawk's webinar folder, I'm going to just rename this. Let's call it Hawk's webinar 1. Sorry, rename. I'm having difficulty with my. Come on. Sorry. There we go. 1, and then I can just move it out of this folder and you know, just delete this this other folder. One last thing that I want to show you, by the way, which is kind of nice, is that if you just go to this Galton 1 and right-click on it and say Show Dependencies, it tells you everything that you have done so far. So, for example, we did a merge, we did a plot, we did several analytics, everything that you have done with this data set. shows up. And in fact, you know, if you want to go to the plot, you just click on the plot and you go to that plot, and you can continue working where you left off. And that is a nice feature that we have. All right, so that ends my presentation. I just want to share some information with you. Let me go ahead and go to my PowerPoint again. Sorry, let me just bring my PowerPoint over. So at Rguroo, we have training available for faculty. And of course, also workshops are available. You can just write to support@softletics.com, and we will provide you with a one-on-one training, in fact, if you need to, or if you want to have training for all of your, for a group of your colleagues, we will provide that. In terms of pricing, all the instructors get immediate complimentary access, regardless of whether they adopt it for their class or not. Students' fees are $20 for 12-month subscription. And here are the ways to actually purchase. Rguroo, you could order it through your bookstore with those ISBN information given through Hawks Learning. You could also, students can also directly buy Rguroo from Rguroo's website. And in order for your bookstore to order it, or you order it for your students, there's a phone number 800-426-9538. So with that, I'm gonna just hand it to Alex and see if there are any questions.
Thank you, Dr. I just wanted to ask everyone, if you do have questions now, you can go ahead and enter those into the Q&A box, and we'll be more than happy to pass those over to Dr. Jamshidian, that he'll be able to help answer those for you. And you can enter those into the Q&A box at the top of your panel or at the bottom. So we do have one, Dr. Jamshidian, and can you do regression by simulation methods?
Yeah, so the regression function itself at this point does not have simulation directly, but in the simulation and probability section of our Rguroo, you can go in and actually do, like, for example, compute bootstrap estimates of your parameters. So at this point, this is not automatic, but in the future, we will have that feature. But if you can do it within the simulation suite of Rguroo. On the other hand, I should mention that simulation methods, for example, in mean inference, bootstrap, or permutation tests and things like that are available automatically, and you wouldn't have to go to the simulation suite to do those, you know, to do analysis based on simulation for mean inference.
Thank you. We do have another question, and there is going to be a recorded version of this presentation, and we'll be emailing that out to everyone. And that'll go over to the emails as soon as you joined in. So everyone will be able to get this webinar and a live on-demand version of that. And it does look like we are just about out of time, but I just really want to thank you, Dr. Jamshidian, and thank everyone for attending today. If you do have any questions following up from this, and those questions come to you later on, please feel free to reach out directly to us at marketing@hawkslearning.com. And we're going to be emailing out that link to the webinar, and we'll make sure to either answer those questions ourselves or get you in touch with Dr. Jamshidian to go further into answering those questions.
Well, thank you, Alex, and thank you, everybody, for attending the webinar.
Great. Thank you so much.